All right, today is about variation equations, lots of different types. So what I have for us first is just some examples before we get to the practice sheet of what direct variation is. A direct variation equation, this is what's going on, guys. Like, as whatever is on the x-axis increases, the same thing will happen to y in that scenario. So if x goes up, y goes up. Here's some examples. Like, as time increases, you see that time I have on the x-axis, the amount of money someone saves could also increase. You know, like, you see a direct variation relationship with that. As time increased, same thing with money saved. Or another example is as the temperature outside increases, you know, like if we're outside and the temperature's going up, the number of drownings goes up also in that case, because more people are swimming, things like that happen, so that's why there's more drowning. So there's a direct relationship with temperature and drownings in that case. You know, like here in Kansas, if it's 0 degrees outside, I'll bet very few people drown. It can happen, you know, people get on the ice and they break through and stuff like that, but not nearly as often as when it's like 95, 100 degrees in that case. So you can see it in a table. Tell me about the x's as I go. Are they getting bigger or are they getting smaller? Bigger? What are the y's doing as we go the same direction, bigger or smaller? As x gets bigger, y gets bigger. That's a direct variation. Cool. So there's also an inverse variation. Inverse, as x goes up, y will go down in that case, or vice versa. So the time since you plugged in your refrigerator, let's say you bought a brand new refrigerator, as the time goes on, that gets bigger. As you plug in your fridge, the temperature in that fridge, shouldn't it go down for a little while, you know? Because it's like, hey, you bought the fridge, it's at room temperature, you plug it in, and you want it to get to 40 degrees, shouldn't that start going down? And yes, of course, it will settle at what you want it to be. But my favorite inverse variation relationship is if we go into the weight room. And I'm not saying anyone here has to lift weights, but y'all know what bench press is in that case, right? Imagine, when can you bench more? How many reps is what I'm talking about? When the bar is empty or when there's a lot of weight on it? What do you think? Empty bar. So like the number of reps you can do with the bar empty, as the weight you put on it increases, would you believe the amount of reps you can do decreases in that? Like empty bar versus 225 pounds, I think you can do a whole lot more with an empty bar versus a heavy weight. So as the weight goes up, the reps go down in that case. Does that kind of make sense to you? So we've got some basic generic equations. I got these all typed out for you. Please note that they are generic. We have to let the story do some of the details for us. So we talked about direct variation, and we've talked about inverse variation. There's also joint and combined variation. But would you notice that all 4 of these variations have what's called a k value in it? This is what the scientists are looking for. So there's research done in some real-world scenarios. I have a couple stories. They find the relationship that's going, like, oh, if this increases, that increases, or if this increases, that decreases, and things like that. Sometimes there's more than one variables involved, but there's always this constant of variation. So here's what I'd like to notice. In a direct, forget about, let's just notice k. First of all, let's do that. Where's k located in all 4 equations, upstairs or downstairs? It's always upstairs. K is always upstairs. Where's x located in the direct, up or down? I was trying to switch colors there. Up or down? Up. So direct is up. And where is x located in your inverse variation? Down. Inverse, basically today, is the only time you'll start putting variables downstairs. If we read a story and it tells us the word inverse variation, we got to start putting some variables downstairs. Yes, it happens in combined, but we'll see that later. So let's just start. Here's a story. The amount of bacteria in a dish, they're calling that y. Here's the magic word, varies how? Directly. As the square of the number of minutes in the dish, x. After 6 minutes in the dish, there were this many bacteria. Find the number of bacteria in 14 minutes. Here's how we roll. There's a 4-step process to do this. Step 1 is to write our generic general equation. So let's number our steps. Step 1. And here's the magic. We go look for the word varies, because that's where the equal sign is at. Varies tells us where the equal sign is. So whatever is to the left of the word varies will be on the left side of the equal sign. Whatever is after the word varies will be on the right side. So would you believe that I can start with a y equals, right? Because here's the word varies. Then you always need a k value, regardless of what type of variation they are talking about. You need a k value. And where's k at? Upstairs or downstairs? K is always upstairs, so I'm going to start with that. Then you use the magic word of directly to tell you where the other variables are going. Direct means you're going to be upstairs. It doesn't have to be an x. It's just whatever they tell us. So it says the square of the number of minutes in the dish, and they say, yeah, we want it to be x. But what are they doing to x? Is it to the first power, or are they doing something to it? They are squaring it. So you can see how it's already different than this equation up here. This is very generic, just saying, hey, dude, k is upstairs, the variable's upstairs, but something happened to it. The scientists studied like what was happening to this bacteria, and they could see that there was a squared relationship. As x got bigger, y got bigger, but the x's were happening at a squared rate as opposed to a first power rate. So that's step one, write the generic equation. Step two, let's substitute in and solve for k. So here's some info, right? They give us some stuff. Let's sub in. After 6 minutes in the dish, there were 162 bacteria. Tell me where the 6 can go in for, since it's minutes. Should it go in for x or should it go in for y? X is number of minutes, right? So we can put the 6 in for x. And isn't y the number of bacteria, right? So let's substitute in 162 is going to equal, see, we don't know k. K is that constant of variation that the scientists still don't know. All they could see when they were studying was it was happening at a squared rate. So they were measuring stuff, and they now want to figure out what is the constant of variation that's going on. So we can go ahead and scratch that out and call it a 36 real quick if you would like to. And how do you solve for k? Subtract or divide? What do you think? We got to divide because they're being multiplied. So please, let's punch that in. What is 162 divided by 36? Does it come out nice or does it not come out nice? That ain't bad, right? 4.5. So we'll leave it like so. So the k value is 4.5. Scientists have been looking for that. They're like, what is the constant variation rate that this bacteria is happening? 4.5. So that's step two. Sub in and solve for k. Step three is rewrite step one completely over. But now we know k, so we're going to sub that in. So the actual equation for this particular scenario with this bacteria and this time thing is y equals 4.5x squared, right? Because we figured out the k value, that constant of variation. And now that we have this, it's time for step four, answer the question. Step four says find the number of bacteria after 14 minutes. So, okay, now that I know the equation for the scenario, I can sub in. Where does the 14 go? Does it go in for x? Does it go in for y? X, because it's in minutes. So I'll sub in to show some work, and then we can just punch it in. Remember, the 14 is going to get squared. So 4.5 times 14 squared. And I got 882. Let's label it also. 882 what? Bacteria. So one little story that goes along with it. So that was a direct relationship. As the time increased, the number of bacteria in the dish also increased. But it didn't increase linear. It increased squared, like quadratic in that case. So that was direct. Let's check this story out. The time it takes, in minutes, to clean the bleachers at Lewis Field. So I think most of you have been there. That's where we play our football games at, right? And you know, after a football game, there's some really rude people that leave all their trash behind and all of that instead of throwing it in the trash can. So they have people come in and clean the place up. So the time it takes to clean the bleachers at Lewis Field after a football game, T, varies, there's the magic words, varies how often? Inversely. So if you like to highlight or box or anything like that. So we got an inverse relationship as the number of people cleaning the stadium. Let's think about that. As the number of people are there increases, cleaning up, what happens to the time it takes to get the job done? Does that go up or does that go down? The more people helping, the less time it's going to take. Would you agree with that? That is an inverse relationship. The more people you can get help cleaning up, the less time will be there. Cool? So nice inverse relationship. So let's do step one. Let's write the generic equation. Here's the word varies. There's our equal sign. So what comes before that? It's not a Y this time. They're changing the letters on us. It's a T. Are you okay with that? T is going to equal. Here's the secret. We always need a K value. K should be located where? Upstairs or downstairs? K is always upstairs, so here's my K value. But since they said inversely, I need to introduce the fraction bar because that stuff's got to go downstairs as the number of people cleaning the stadium. They want us to use P. Do we need to square it or cube it or just leave it to the first power? They don't say anything about it, like the number of people squared or the number of people cubed or anything like that. So it's just P to the first power. Are we okay with this? This is the generic equation for this scenario. Step two, let's sub in to solve for K. When there were 3 people cleaning, it took 170 minutes. Remember, T is time in minutes, so we don't have to do any converting or anything like that. So what should I put in for T, the 3 or the 170? 170. I don't know K, because that's what we're trying to solve for, but there were 3 people. Agree with that? Then we just solve for K. There's a divide by 3 here. How do I get rid of the divide by 3? Multiply by 3. And you can help me out. 510, is that right? 510 is our K value. So now we could write a basic scenario for if everyone was kind of doing an equal job and had the same skill level of cleaning. This is the basic thing. The time it will take to clean Lewis Stadium will be 510 minutes divided by how many people are there in that situation. Right? Again, assuming everyone does an equal amount of work and things like that. So step 4, it says how long would it take if 8 people were cleaning? So where does the 8 go in, for T or for P? For P. So please show me that instead of just like punching it in. It is a simple one on this guy, but show me you're going to do the 510 divided by 8. And what does that turn out to be? 510 divided by 8 is what? So it should take about 63.75 watts. That's nice. A little over an hour. 3 people took 170 minutes. 8 people is going to take 63.75 minutes, you know, in that case. So the more people helping, the more. Now, granted, like I said, if some of them were like little kids and they couldn't do as much work as an adult and things like that, there's a little bit of adjustments to make, right? But if everyone's working this equal amount of hardness, this would hold true. Okay with that? So I redid these because they had stories involved with them. The way math textbooks do it is they don't do much stories involved with them. They put these lame, plain Jane problems like this, where it doesn't make any sense because you don't know what they're talking about. Here we knew they were talking about cleaning a stadium, you know. Here we knew, the other one they knew there was bacteria in a dish. So now that we get an idea, let's do these lame Janes and just realize, okay, I don't know what story is involved, but I can still do the math. So first of all, here's the word varies. How do they say it varies? Jointly. All that jointly means is that you have more than one variable involved, right? It could be 3 variables, it could be 2 variables, it could be 1,000,000 variables, but could you tell me where they're all located? Are they all upstairs or are they all downstairs? Upstairs. Everybody's up in the joint variation. So we'll start with step 1. Y varies. There's our equal sign. We need more than just X and Z being multiplied together. There's one little ingredient that I totally forgot. They never mention him, but he needs to be there. Who is that? That K value. Everybody's up in the joint variation. Nobody goes downstairs. So you didn't have to square X or cube it or any of that stuff. Are you cool with they're just all upstairs being multiplied together? Then step 2, take the info they tell you and sub in to solve for K. So if Y is 10, we don't know K. When X is 2 and Z is 4, I'm going to go ahead and scratch that real quick and call it an 8, you know, because they're multiplying those together. But do substitute them in so we can see that you're putting them in the right place. You know what I mean? How do I solve for k? Should I subtract 8 or should I divide by 8? Divide. Let's do this one as a nice, neat fraction. It'd be 10/8, which, are you cool with that being 5/4? If you put the 1.25, I probably wouldn't mark you wrong, but it's nice to have the fractions when there's like an inverse relationship or a joint or a combined variation where there's already a fraction bar in there. You can't put a decimal inside of a fraction. So that's why I want to roll with the fraction here. Even though we don't have what, we'll see that soon. So step 3, start over. Y equals 5/4 xz. Just substitute that guy back in for k. And now answer the question. So they say find y. Sometimes you'll have to find other things when x is 4 and z is 3. I can see that this times 4 and divide by 4 are totally canceling each other out. And I'm left with 5 times 3, which is 15. There's no label. There's no story to this whatsoever. It's very, very dumb, in my opinion. It's like, who cares, you know? But it's like, to me, it makes more sense. Is like the amount of teens smoking varies jointly as their age in this scenario and the place that they live or things like that, you know? It's like, if there's a story involved with it, I think it makes a lot more sense. But let's keep rolling. Find the word varies, and what's our variation? It is, ooh, read the whole thing. You're right about that saying directly, but do they also give you the word inversely in there? That is called a combined variation. They will never say varies combinedly or anything like that. What it means is you've got the word direct in there and the word inverse. They're like combining them together. So let's start with step 1. It says A. Varies is our equal sign. We always need a k value. Where does k go? Upstairs or downstairs? And I'm going to start with my fraction bar because they did mention inversely. So I'm putting k upstairs. And here's the easy thing about combined variation. Anything that says direct, guess where those variables are going? Upstairs or downstairs? Up. Anything that says inverse, guess where those are going? Down. So directly as B and inversely as C in that case. And here's the secret to success. Out of all of these crazy formulas that you see up there, there's only one time when you're putting a letter downstairs, and it's got to say inverse in front of it. Right? It's got to say inversely. Every other letter goes upstairs. K, whatever they're talking about, the only time you put somebody downstairs is when they say it's inversely. So, all right, I'll let you and a neighbor substitute in and solve for k, and then come back with me. Or, since you're out there in video land, don't go over to your neighbor's house. Just do it yourself. Pause the video and check with me. So we noticed in class that they had some rearrangement. The blue sentence right here is the one that gives us A, B, and C. We need that to do step 2. The only thing we shouldn't know is K. So I got to put all this blue information. They say A is -2, K we still don't know, B is 4, and C is 3. So I have to use this blue sentence, even though they wrote it out of order. I'm going to multiply by 3 first, get a -6 over here. I'm going to call that 4k instead of k4. And then I'm going to divide by 4. And I'm going to leave it a fraction. That's what I was talking about earlier. Instead of putting it -1.5, we can't put -1.5 back in for k because that's a decimal. You can't put a decimal inside a fraction. It's not proper. So to rewrite this guy, I'm going to do A equals, hey, since k is a fraction, you definitely can't put a fraction all upstairs either. Put the numerator in the numerator and put the denominator in the denominator. You know, -3 is the numerator of k. The denominator is 2. It's just like if you had a whole number for k of 4, you put 4 in the numerator and you put 1 in the denominator in that case. So we'll do it like so. And then we had a B and a C in these places. So when k is a fraction, numerator upstairs, denominator downstairs. It says find B when A equals 10 and C equals -5. So I won't know B, and 2 times negative 5. And I'm going to scratch that guy out and call that a negative 10 right away. Multiply, negative 100, and then divide. See, that's a repeating decimal, so I'm just going to leave it as 100/3. But please make it positive. Don't put a negative over a negative in that case. I don't want 33.3 repeating, so how do you feel about that idea? Jointly, everybody's upstairs, combined, direct up, inverse down. Please try to do step 1 with your neighbor and then check it with mine. Or pause the video, do step 1, and check. Okay, so let's see. Which one of these is correct? Oops. Didn't even want to make that a choice. The red one or the blue one? Which one of those do you feel is correct if y varies inversely as the square of x? Red one or blue one? So the correct answer was the red one because they wanted x to be squared. If they wanted it to be square rooted, they would have said. So now that we have the right equation, see if you can get the whole thing done. Please pause the video, do step 2, solve for k. Step 3, rewrite, and step 4, answer the question. Here's what I got. I ended up subbing in and solving for k. A lot of people forget to square the number, like when they get it in. They're good to hear, and then they do like y equals 20/8. And it's like, whoops, you got to do 8 squared in that case. So just watch out for that. Cool. Let's do it again. Let's write line 1 of this guy. Line 1. Y varies directly as the cube of x. What is wrong with mine? So 81 equals. And then 81 equals k times 27. And if you divide, what did k turn out to be? Was it 3? Do step 3 now. Start over. We found k. Hooray! And answer the question. So find y when x is 9. Y equals 3 times 9 cubed. Hey, what's 9 cubed without a calculator? 729. Take it times 3, you could probably use a calculator for that in that case. What did we get? 2,000 what? 977? 187? Not too bad, eh? Not too bad. Let's see. Let's go to 4 on this page. We can skip 3, go to 4. See if you can do step 1. Pause the video so you can do step 1 and come back and check it with mine. I got y equals, I need a fraction bar. Where's k? Up. Where's z? What do you think? Where's z? Upstairs. Please cross your z so it doesn't look like a 2. And where is the x? Downstairs. Is anything happening to the z or the x? Anything happening to either one of those? X should be what? Well, what some people argue, they're like, but nope, Miss Farnsdale, that's not how the equation goes. You have x upstairs and z downstairs in the formula that you gave us. This is a very generic formula. All it is saying is there's some letters upstairs and downstairs. You have to do what this story tells you to do. And that z needs to be upstairs because it says direct, And the x squared needs to be downstairs because it says inverse. Cool? Continue. Do the other 3 steps of this. Pause the video. Check it with mine when we're done. So I got this far. I found k to be negative 36, but it gets a little weird here. Find x. So they give me y as 9. And I know this was a negative 36. Z was negative 5. But they want me to find x. Well, it's being squared down here also. I don't like him downstairs. How can I get rid of this? Divide by... Yeah. How can I get rid of this? Divide by x squared. Multiply by x squared. And that turned out to be 150, 180. Is that right? And divide by 9 first. Please do not square root. It bothers me so much when people square root both sides right away. You got to get x squared by itself first before you can square root. So that turns out to be 20, right? And then x equals plus or minus the square root of 20. In that case, you do need a plus or minus because you don't know anything about the story in that scenario. You can simplify the radical if you want to be 2 square roots of 5 if you're interested in that also, right? But I'd accept plus or minus the square root of 20. All right, let's do the last ones really, really fast. They say state whether it's direct, joint, inverse, or combined variation. Then find the constant of variation. So you tell me, are there variables downstairs? Yes or no? How many? 1? How many variables involved besides the p, right? The p doesn't matter, right? Over here, how many variables involved besides the p? Just 1. So you only got 2 choices in my eyes. It's either inverse or combined because direct and joint have nobody downstairs at all. Is this inverse, which only has 1 variable involved, or combined, which has some up and some down, variables? What do you think, inverse or combined? This is inverse. Who is the constant of variation? Who is the k value? 4. So we'll do it like this. We'll say inverse variation and k equals 4. Inverse variation and k equals 4. Then you can do the last 3 of those with your neighbor, or you can pause the video if you're watching at home and try those. Are they inverse, direct, combined, or joint? Combined has some variables up and down. Joint, everybody's upstairs. Direct, only 1 variable upstairs. What was this? Direct. What was this? Combined. And what was this? Joint. So that was direct with a k value of 12, combined with a k value of 13, and joint with a k value of 1/2. Anybody know what this is right here, just out of curiosity? Area equals area of a triangle. That's a joint variation. The area of a triangle varies jointly as 1/2 of the base and the height multiplied together in that case. That's where all of our formulas come from. They are some sort of variation. Lovely. If you have any questions, let us know, man. Have a great day, or evening, or morning, whenever you're watching this dang video. Website called